My name is Kevin Jones. I'm a DevRel engineer working for Edge and Node. So I work on the Graph protocol. I'm also in the Build Guild. I support Scaffold ETH. We're going to be talking about specifically the graph and how you can build a subgraph. And we're going to talk a little bit about how you can query it and some of the tools and developer tools available to you. Again, my name is Kevin. First, we're going to cover what and why the graph exists today. And then we're going to look at actual configuration files, how they look on the graph, what the architecture looks like, and we're going to try to do a demo too. So first of all, why do we need data indexing? This is kind of a common thing. People don't really quite understand the purpose of something like the graph. So if we think about Ethereum transactions, we have users that are making transactions to specific functions. If you're a good smart contract developer, you probably have events that are being emitted, right, on those transactions. And that's all great for real-time events. You can kind of parse that stuff pretty easily in the UI. Something that happens, it can trigger an event. But really, when it comes to large amounts of data structure and changing of the data structure of a particular dApp, it can get a little crazy, especially as the user base increases on that dApp. And so, if we look at an example of the CryptoPunks here, we have all of the current owners of all the punks. And as these kind of switch hands or are sold or whatever, put up for sale, all of this data that's coming in through the events of an NFT, really that's what the graph aims to solve, is to try to store this data in an easy queryable way. The original idea for a dApp was to essentially write your user interface in HTML, JavaScript, CSS, and then use the blockchain for both incentivization for writes, but also for reading. But when it comes down to it, the JSON RPC for most blockchains is not really incentivized for reads, right? You pay some gas to write to the blockchain, but there is no really good interface for reading large amounts of data from the blockchain. So that's another issue. We also want to try to solve for provenance as well with the graph. So if you want to know exactly what happened to a specific punk at a certain time in the history of the blockchain, it can be very difficult to do, right? You need to know exactly what block that transaction happened, and then, so that's the graph kind of aims to create more of a way for you to go back in time and see all of the history of a particular smart contracts data structure. We also saw something like this actually in the wild where someone was trying to get all of the NFTs in a particular wallet. And so if you're trying to, in this case, they said, okay, well, how many NFTs do they have? And then they went through and looped and created this kind of large object and then pushed those results. And then this is great if you only have 10 NFTs or something in your wallet, but if you have hundreds, I mean, I have at least 200 NFTs in my wallet from different events I've gone to and whatever. This could easily cause your application to have a really, really slow response time. So this is where the graph comes in. And by the way, I'm just trying to go quickly through these slides so we can get to the demo. But I'm going to be here to answer questions if you have them. So there's over 200 indexers on the network today. There's over 90,000 delegators. It's probably actually more than that are actually delegating stake to the network. There's actually this is also higher, over 600 curators that are actually signaling for subgraphs. And there's over 6,000 subgraphs. So these are subgraphs or APIs that are deployed to the decentralized network that are providing blockchain data in a decentralized way. And we serve anywhere between 1 to 2 billion queries per day in certain scenarios. And so the idea is the blockchains that we support are kind of a sea of mess of transactions, and there's a lot of data there that can really be utilized. And so the main purpose of a subgraph is to create these individual APIs that we call subgraphs, right? These little buckets of data. And so another really powerful thing about the graph is we utilize GraphQL. And as you saw that previous example that someone was doing some JavaScript looping to create this array, you can really simplify any kind of query to the data structure by just making a simple GraphQL query. And so in this case, we're querying all the NFTs by owner for a specific address. And we are actually just getting all of that data and the previous owners of all the NFTs as well in just one single query using GraphQL. And so that's one of the huge powers of the graph. So this is what we actually aim to do, is to replace the read layer for a blockchain, right? So you're still using the blockchain for writes, you're still paying your gas, doing all that good stuff, but as the event data comes off, we have the graph sitting at an indexing layer for indexing. There's 3 main config files to a subgraph. It's the manifest, which is kind of like the YAML, the high-level configuration. There's the schema, which if you've ever worked with GraphQL, you'll be familiar with the schema.graphql file, but this is like how you want to actually store the data inside of the database. And then there's the handler, which basically processes all the data, right? This is how we actually go through the data, listen for the events, and then put it into the database. And this is all written in assembly script, which is a subset of TypeScript. So you get the type safety, but it's not quite as powerful as TypeScript because you can't do some like imports and stuff. But for the most part, it's compiles down into WASM. That's where it differentiates a little bit from TypeScript. And it allows you to do some really cool, interesting data processing of the data as it comes off of the chain. So it looks kind of like something like this. Consumers can make a request through the network, right, by making a GraphQL query. The graph node, which is a Rust implementation of how the indexing works, so it handles all of the data processing and the query layer. We'll go back to the Postgres database that the indexers run, and we'll do a SQL query, and it will also optimize that query for performance, and then it will send the response as GraphQL. So the graph kind of sits, again, as this like middleware. And then we look at something like this. This is just a simplified version of what I just showed you, or a more expanded version, where you have your dApp. You still are doing your transactions to the blockchain, to your smart contracts. Your smart contract emits events. The graph node processes those using the WASM module, stores those into Postgres, and then just exposes those with GraphQL, right? Really straightforward. Okay, so one of the coolest things that we've done lately that I think is really awesome is we've added a extension into Scaffold ETH. Who here has used Scaffold ETH before? Anyone? All right, I love that. Okay, so Scaffold ETH is great because it has a full stack experience, right? So it's got Next.js with full TypeScript support and coding, and then it also has Hardhat or Foundry. So, and it has this extension system that is being added, and the very first extension added was a subgraph support. So you can run npx create-eth at latest with the -e flag subgraph, and it will spin up the monorepo for you, the full stack with Scaffold ETH, and the graph running inside of Docker with an example subgraph, with an example smart contract, like literally just like a great boilerpoint starting point. So I would definitely recommend you guys check that out. Let's see how much time I have. Cool, got 10 minutes. We also have a Telegram chat for support. We are also in the Discord, so if you can't find us at the booth for some reason because it's late, you can join this Telegram chat. I would say this is probably the best way to get a hold of us, but we also have Discord. We're there to support you, but you can also stop by the booth, okay? Okay, let's do a demo. So we are going to, I'm going to try to actually do 2 demos. I don't know if it's going to happen, but we're going to try it. The first one I want to do is I actually want to run the subgraph package and show you how quickly you can set it up. So we can do npx create-eth at latest -e subgraph, right? That's exactly what I showed you earlier. That's going to basically run this script that says, hey, what do you want to name your project? If you haven't installed the package, you need to install it. So let's just call it, we'll just call it demo. It's going to ask you what chain you want to use. You can use Hardhat or Foundry. So we're going to use, let's use Hardhat. Do you want to install the packages? Yes. So then this is going to basically scaffold out a full stack dApp for you with Next.js. In this case, I chose Hardhat. If you chose Foundry, it would have Foundry. It's going to create an empty Git project. It's also going to use the subgraph extension. So there's going to be an additional repo for the subgraph. And inside of there is a full working subgraph. So we'll give that 1 second. While that's doing that, I want to show off the graph, what we have in the graph.com. So there's 2 main areas that you'll probably spend most of your time. The first part is the Explorer, where we have all of the existing subgraphs. So there is a bounty for the best use of an existing subgraph, and then there's a bounty for the best new subgraph. So if you want to use an existing subgraph in your app, that's great. You can come here, search for it. Like let's say you want Uniswap, it's right here at the top. We can click that and see the v3 subgraph, and we can start getting the data we want from there. And if we come down to the bottom, there's this really cool new feature where it will show you exactly how to query it. So this will give you the curl, this will give you React, this will give you Next.js, and Node.js. That's really, really awesome. That's actually a new feature. And you can query the network in your dApp just by putting that boilerplate code in. The next place you'll probably spend a lot of time is the studio, and that's if you want to create a subgraph. So we're going to try to do that in a sec too, but let's see how far we get. Okay, our dApp's scaffolded. It's called demo, right? So let's go. We're going to start up our chain. So everything in Scaffold ETH is like yarn commands, which make it really easy for you. And this is all in the documentation, so don't feel like you need to memorize these. But I'm just going to show you how quick it is. So yarn chain to start up our blockchain. Yarn start to spin up our front end. We're going to go into the demo folder again. We're going to do yarn deploy to actually deploy the smart contract that comes with the demo. That's going to take it, push it to Hardhat. You see that there. And then this last one, we're going to do yarn run node. Now, the subgraph extension requires Docker because we're going to run everything in Docker. So what happens here? Oh, we got to. That's not good. Let's see if we can shut down these containers real quick. The demo gods are mad at me today. Okay, let's try this. There we go. Okay, so the graph again is a kind of like, what we're doing here is we're like virtualizing an indexer stack. So we're running IPFS for all of our manifests and stuff like that. We're running graph node for the processing, the Rust implementation, and we're running Postgres to store that data. So it's kind of like a virtual indexer, right? It's like basically you're like bypassing having to use the studio. And so now we have you know it's working when it says downloading latest blocks from Ethereum. And now we can basically come over here and deploy our subgraph. So local create creates a subgraph, and local ship will send that. So again, this is all in the documentation on the README, so you can basically find it there. If you need help, just come talk to me after. I'll point you to where it is. But we're going to deploy the subgraph locally. And then we've deployed it. So we chose a version basically for the subgraph because you need to version the subgraph. But if we look at Scaffold ETH now, so Scaffold ETH is, again, it's a Next.js application, and it works on port 3000. So hopefully it loads here. Okay, so here we go. We got Scaffold ETH. And what you'll see is Scaffold ETH comes with this kind of like very basic contract. It's called a greeter contract. And you'll see here that we have it's been deployed to Hardhat. It has this greeting, and then it has a reader for a counter, and then it has a way to set that greeting. So Scaffold ETH is this kind of cool tool where you can like basically use this burner wallet function. You have this burner wallet that's available to you, and then you can come here and change the greeting basically. So I went and got some gas here from the faucet, and then now I can basically make a change to this greeting. So it's a very simple smart contract. We'll just change it real quick. We'll say, hey, what's up? Something like that. What's up? And then we'll say send. And then we'll say, I don't know, Brussels, and send, and hello. If I could type today. Bad typing today. Okay, so I just sent a bunch of messages, right? I basically sent these events, right? I changed my event like 3 times, basically, or I changed my variable 3 times. So I should have 3 events. So if we go here to this, when I did the deploy, it gave me this GraphQL window. So we can go there and open it up real quick. And what we'll see is this Explorer section here, where we can basically explore all of the entities inside of the configuration. And so we care about greetings. We can get the first 10 greetings, their ID, the value, stuff like that, and then hit play, and then we'll get that data back. Oh, we didn't actually get the greeting, so let's grab that too. So then we'll see that we're able to make one simple GraphQL query to get all the data that we need in our application. There's also a tab on the Scaffold ETH here called Subgraph. that you can see here at the bottom that it shows you exactly the events that come back, and then we do this kind of cool stuff with the address. And here are those commands too: yarn run node, local create, local ship. And then if you need to clean up all your data, you can run clean up. I just want to show the config files really quick so you can kind of get a feel for like how the scaffold or how the subgraph configs look, because I kind of briefly touched on them, how they work, but I want to show them in detail. So if we go to in this case, we have a packages folder with a subgraph. Here's the subgraph folder that you basically use when you use the extension. And if you come here, you go to the YAML file is here, the subgraph YAML. It basically is kind of like the high-level config file. It tells exactly what network that you are creating a subgraph for. It tells you like where to get the schema, which is like how you want to store the data in the graph. It also has the address for the handler, the mapping, and it also has the handlers listed here, and then the ABIs for the contract. So it's kind of like this high-level, way to point everything in your subgraph to the proper locations. And so if we go to this SRC folder, we'll find those two files that it's referencing. So the first one is the schema, which is like the data types. So in this case, this contract that I deployed and tested with has a greeting, and then it has someone that actually sends those greetings, right? So it technically has two what we call entities. And so what you'll notice here is this is actually a more advanced subgraph because it's linking the senders to the greetings. And so you'll see here that we're referencing sender as sender, and we have all the greetings in this kind of like virtual array. So what's really cool is Graph Node will determine that if someone sent a greeting, it will link those together with a relational like database link in the backend that you don't need to worry about, so that when you query, you'll be able to get all the historical data for that. So it's very advanced, the stuff you can do with GraphQL. And then the handler is this part, which is probably a little more confusing. I probably won't go through this completely, but this is how the data is actually being processed and stored. So again, it's all assembly script, and it's very, it has type safety, so you can import and kind of work with the data as it comes off. You import the schema, and you can basically do things like load, which is to like see if that data already exists in the database. And then you can do kind of like if statements. If it doesn't exist, create it. You can do some like mathematical calculations. Obviously, you can do a lot of stuff with assembly script. And then at the very end, you can like save that data. So all this data is stuff that's coming off of the event. I know I'm almost over, but I'm almost done. So there is this right here where the event comes in, and in this case, it's called the greeting change. And we just get all the data we care off of the event parameters, right? So parameters, and then we also get stuff off of the block timestamp as well. So there's a lot of cool stuff you can do with this. And lastly, just real quick, if you don't want to use the subgraph extension and you want to create a subgraph, you can do that just by clicking here and name it whatever you want. So we can just say test, testing, testing 1, 2, 3. I've done this too many times. And it will give you all the steps to create a subgraph right here. So everything you need to know is also here. If you don't want to do the full stack thing and you just want to create a subgraph for any of the supported chains, you can do that there. Cool. Thank you, guys.
Yeah.